Okay, so today we are, I think, starting center of mass, right? Okay, sure. So, अभी तक हमने what have we studied up till now? So up till now we have studied the mechanics of a single point particle or a system of point particles consisting of more than one point particles, but under a very strict condition. Okay, so first let me discuss what we have studied about point particles, and then I'll talk about what we will study. So the concept of point particle I introduced to you, and the concept of point particle is simply that we take an object of real life and we convert it into a point particle having no linear dimensions. And then we construct a frame of reference, which is nothing but an XYZ axis, and we study the motion of this point particle in this frame of reference. The way that we study this motion is that we have position vectors, which gives us the displacement vector, and we have the velocity vector of the particles, and the difference in the velocity vector, this gives us the acceleration vector. So this is dv, and this is dr, and then we define for a point particle the concept of velocity, which is equal to dr by dt, and we define the concept of acceleration for a particle, which is defined by dv by dt. And then, of course, there is a whole chapter of motion where we say that, okay, fine, let's confine ourselves to one dimension. So in one dimension, acceleration may be zero, acceleration may be constant, acceleration may be variable. In two dimensions, acceleration may be zero, acceleration may be constant, acceleration may be variable. We have seen all cases, right? In one dimension, of course, that was motion in one dimension. We studied it separately. In two dimensions, acceleration is constant. We studied projectile motion at length, and acceleration is variable. One case we studied was circular motion. Right? So circular motion is two-dimensional motion with variable acceleration. After having studied kinematics, what we did was we studied the Newton's law of motion, F is equal to ma. And we saw that this equation in itself is, I mean, if you are lucky, then this equation in itself will give you the answer. But in all probability, what is going to happen is that you are going to need something else apart from this equation. So we learned the concept of the string constraints, we learned the concept of wedge constraints, and we learned the concept of pseudo forces. And then we learned the concept of work energy theorem, which was delta W is equal to delta K. And then we learned that work done by conservative forces can also be written as minus of delta U. Right? So all these things, all these concepts we have learned for a point particle or a system of point particles whose acceleration is the same. So work done by conservative force. So if I gave you a problem wherein there were three blocks like this being pulled by a force F, then what you can do is you can consider this as a system of a single point particle. However, if I give you a wedge with a block on it, then you cannot consider this as a system of point particles. At least you cannot consider it as a system of point particles under the framework that we have studied. So what I am going to do, Turga, I don't know. I think it is on Sunday, right? So what we are now going to do is that we are going to consider a system of point particles. And just like mechanics, I am going to deal with the system of point particles in exactly the same way that we dealt with single point particles. So basically, what we are going to do is that for a system of point particles, uh, we are first going to define what is the position vector, then we are going to define what is the velocity vector, and then we'll be able to define the acceleration vector, and then we'll move on to the second law or the Newton's laws of motion for a system of point particles, and then we'll move on to the work energy theorem for a system of point particles. So basically, all the mechanics that we have learned up till now, right? And that is why I took a lot of time in doing this. Uh, the reason is that now I'm going to revise it, but of course, it will be much quicker than before. But every concept that we have learned up till now will be revised, but this time from the perspective of a collection of point particles. And then in the next chapter, again, we are going to revise each and everything, but from the perspective of a rigid body, right? And since a rigid body is capable of rotation and translation, things will get more voluminous. The description of motion of a rigid body will get more voluminous. There will be other variables which will be required apart from the variables that we have already learned and studied. Okay, so this is the story of point particles. Okay, so now I want to talk about system of point particles. Okay, so there is some universe, there is some place in space, hypothetical, of course, imaginary, where there exists only five particles: particle 1, particle 2, particle 3, particle 4, particle 5. Nothing else exists in this universe. Just एक minute, I'll just pause for 2 minutes. Sorry. So there is this hypothetical universe where there are these five particles, and what I want to do is I want to talk about the location. Yeah? So how to locate? That is the question. Because point particle के लिए तो it was simple. The way to locate a point particle was through a position vector. Because we have individual point particles here, so there must be individual position vectors. So there is R1 here, there is R2 here, there is R3 like this, and similarly there is R4 like this, and then we have R5. So now the question arises that to specify the position of the system, should I use these five position vectors? What happens if you have 100 particles in the system? What happens if you have 1,000,000 particles in the system? If you have 1,000,000 particles in the system, will you know the position vector of all the particles? Yes, of course, you should know the position vector of all the particles. If you know the position vector of all the particles, should I write the position vector of all the particles? Should I? No, this is the question. So the answer is that since we have been working for so long with a single point particle, it is better always to convert this system of point particles into to convert the system of point particles into a single point particle. Now, how can we do that? Well, so we have particle 1 here, we have particle 2 here, we have particle 3 here, 4 here, and 5 here. So, what I'm saying is that this system of 5 particles is converted into a system of a single particle, and this single particle has the mass which is the sum of masses of all the particles, and it has a position vector. It has a position vector. This position vector will be the location of the system of point particles, and therefore this will be called the position vector of the center of mass. Right? So basically, if a system of multiple point particles is is mathematically okay, this does not happen in real life. You know this, right? I mean, car जा रही है, सड़क पे तो अचानक point particle नहीं बन जाएगी. So mathematically, uh, if a system of multiple point particles is mathematically represented by a single particle, then its location is called the center of the system. Then its location is called the center of mass of the system. Okay, so I will call this RCUN, position vector of the center of mass. Please take a screenshot. I'll go to the next slide, and in the next slide, we'll actually work out how to locate the center of mass of the system. Right. So I'm going to the next slide. Please take a screenshot. And since this is a new chapter, let me tell all of you, अगर पीछे कुछ छूटा हुआ है या पीछे कुछ क्लैरिटी में कमी है, तो यहाँ पे we can cover everything up, each and everything that I have discussed previously, I will be discussing it again. And each and everything that I will be discussing here, I will be discussing again in the next chapter. Okay, it will be faster because now you know the terms. I don't have to now introduce the terms to you. Okay? So how to find the center of mass? Well, everybody knows how to find the average of a quantity, right? So if I ask what is the average height of people in this class, then the average height will be calculated uh, by adding up the heights of all the people divided by the number of people, right? Sum upon number. What if I asked you that there is a box of nails? Right? So there is a box of nails, and in this box, I have 100 nails of 1 centimeter and one nail of 5 centimeter. What is the average length? So I don't want to write this. I want to write average length will be equal to how much? Right. Now this you can do very easily. 100 nails हैं, 1 centimeter की one nail है, 5 centimeter की. So you will say that it will be equal to it will be equal to it will be equal to 100 into 1 plus 1 into 5 divided by 100 plus 1, right? So I am interested in these guys. Okay? I am interested in these numbers. So it turns out that this guy and this guy, mathematically, of course, you can work it out. Mathematically, it's very easy to work out the average, right? Have I discussed how to work out the average of a continuous quantity? मालूम है आता है सबको एवरेज क्वांटिटी कैसे निकाल एवरेज ऑफ ए कंटिन्यूअस क्वांटिटी right? I don't think I have. Maybe in kinematics I would have, but मैं करता हूँ राइट. मैं ये लेक्चर खत्म हो रहा होगा उससे पहले जस्ट रिमाइंड मी. नहीं molar mass is different. Average of the continuous quantity. We'll use integration instead of summation. That's at the end of the chapter. Remind me. I'll okay. So these guys, the things that I have circled, they are called weights. Okay, and this length that you have actually worked out, this average that you have worked out, is called the weighted average of lengths. So basically what is happening is that here I am saying that look, length is equal to 1 centimeter has a weight of 100. Okay, this has got nothing to do with the weight that we have studied in physics. This is mathematical. And L is equal to 5 centimeters has got a weight of 1. Right, so 1 centimeters has got a weight of 100, whereas the length of 5 centimeters has got the weight of 1. Okay, again, please don't confuse. This has got nothing to do with physics. Okay, length का weight अगर physics में बोल दोगे तो physics teacher अपने बाल नोच लेगा. But यहाँ पे मैं maths की बात कर रहा हूँ, right? So there is, when I wrote the average wala formula, I see it is 100 into 1 plus 1 into 5 divided by 100 plus 1. So I will classify, or I will call this the weighted average, and I will call these two numbers 100 and 1 the weights of lengths 1 centimeter and 5 centimeter respectively. Now, without working out, without actually mathematically working out, I want to come to a conclusion as to if in this box there are 100 nails of 1 centimeter and one nail of 5 centimeter, and if I work out the average, okay, which I'm not really going to do, but if I do work out the average, then what will be the value of the average? Will it be nearer to 1 or will it be nearer to 5? I mean, will it be like 1.1, 1.05, or will it be like 4.9 or 4.95? And the answer, of course, is very obvious because most of you have worked it out. It will be nearer to 1, right? So weighted average का मतलब ये हुआ कि जो एवरेज क्वांटिटी है वो उस तरफ लीन करेगी या उस तरफ जाएगी जिस क्वांटिटी का वेट ज्यादा है. So in physics, yeah, in physics, we say that center of mass is the weighted average, is the weighted average of position, right? So basically, we are going to have an average wala formula. So it will be of this sort, and it will be weighted average. So there will be weights involved. Okay? There will be these weights involved. So we have x coordinate of center of mass. So supposing that we have particle 1 which has mass m1 and it is located at x1 comma y1. We have particle 2 which has mass m2 and is located at x2 comma y2, x2 comma y2, and so on, right? Then the weighted average of position is center of mass. So x coordinate of center of mass will be equal to m1 x1 plus m2 x2 m3 x3 whole divided by m1 plus m2 plus m3. Similarly, the y coordinate of center of mass will be equal to m1 y1 plus m2 y2 plus m3 y3 whole divided by m1 plus m2 plus m3. So the position vector of the center of mass will be equal to x cum I cap plus y cum j. There is a z, of course, here also, which I have not written, but the third coordinate will play similar and an equal role as the first two coordinates. Right? So this is the key takeaway from this discussion. This is how we will find center of mass of a system of point particles. This is how we'll find the center of mass of a system of point particles. So please write this down and then we'll discuss questions. हो गया, लिख लिया? Can I move now? Ah, so basically, what you have to do is you have to find. This is an exercise of. I don't like to give this question. Uh, all you have to do is really work out the coordinates and that's it. तो आराम से हो जाना चाहिए. 0, 0, 2, 0, and then this would be इसके coordinates क्या होंगे? इसके coordinates होंगे √3, 1 या √3/2, 1 याद नहीं आ रहा मेरे को क्या होगा. 1, √3. Sorry, yes. हाँ, 1, √3. So the x coordinate of center of mass will be 1/√3 आ रहा है. अच्छा, √3 से divided. Okay. It will be 1 into 0 plus 2 into 1 plus 3 into 2 whole divided by 1 plus 2 plus 3. That is equal to uh, 8/11. 8/6 आएगा ना बच्चा. 4/3 आएगा ना. Y coordinate of center of mass 1 into 0 plus 2 into √3 plus 3 into 0 divided by 1 plus 2 plus 3, that is equal to 2√3/6 is equal to 1/√3. Question number 2. नहीं नहीं सबका सेंटर ऑफ मास पूरे सिस्टम का निकालो. नहीं तरुण, गलत। हाँ, यही तो सोचना है ना हर दिन। ऐसा कैसे हो सकता है? हाउ कैन दैट बी? इफ यू टेक अ चार्ट पेपर with respect to point O to the point O देखो मैंने बनाया हुआ है. If you take a chart paper and if you cut a circle and a square out of it, will they have same mass? बहुत बढ़िया बात है. नहीं, खुशी गलत आंसर है. Okay, chalo. So let me show you how this is done. I'm just changing the slide for a moment. So what you have to remember or what you have to understand, Pratiksha. What you have to remember, what you have to understand is that, which I have not told you, I wanted you to draw the conclusion yourself. It's actually quite obvious. But you have to remember that symmetrical objects, symmetrical uniform objects have center of mass at geometrical center. अब इसका मतलब क्या है? What is the meaning of symmetrical and what is the meaning of uniform? हाँ चेतन. What do we mean by symmetrical and what do we mean by uniform? Well, symmetrical का मतलब you already know. So if I have a circle, which is, if I can draw it better. So if I have, I don't think I can draw it better. So if I have a circle, then the circle is symmetric uh, because of the fact that if I were to draw an axis like this, right, then whatever coordinates exist in the first quadrant also exist in the second quadrant, also exist in the third quadrant, also exist in the fourth quadrant. So this is symmetry. Now, why am I treating this as symmetry? I'm treating this as symmetry. I'm treating this as symmetry because if this circle is made up of point particles, then there are an infinite number of these point particles. And if I were to consider a point particle here, right, then there would be a mirror image of the point particle here, there would be a mirror image of the point particle here, there would be a mirror image of the point particle here. Now you may ask, अरे इससे क्या फर्क पड़ता है? इससे फर्क ये पड़ता है कि अगर इसके कोऑर्डिनेट्स a, a हैं और इसके कोऑर्डिनेट्स -a, a हैं और इसके कोऑर्डिनेट्स -a, a हैं और इसके कोऑर्डिनेट्स a, a है, राइट, और सबका मास m है, राइट. एक्चुअली मुझे dm लेना चाहिए. And then if I find the x coordinate of center of mass, I find the y coordinate of center of mass, I am going to get a 0 and a 0. So you take any 4 pairs of, I can't say 4 pairs, but you understand what I'm saying. Take any set of 4 particles which are symmetric to each other. So for example, this guy, this guy, this guy, this guy. And when you calculate the center of mass, when you put it in the formula, you always get a 0. Right now, since for every particle in the first quadrant, there is a corresponding particle in the second, in the third, in the fourth quadrant. Therefore, the center of mass of this disk must be here. If this was a sphere, then there would be 8 corresponding point particles. If you remember, I don't know, मैंने क्लास में डिस्कस किया कि नहीं किया. Generally, kinematics के time पे, when there are 3 dimensions, then you don't have quadrants, you have octants. So there would be a comma a comma a, there would be minus a comma a comma a, there would be a comma minus a comma a, there would be, all those permutations and combinations. So basically, you are going to end up with again a center of mass x and y coordinates as 0. Now, what is the meaning of uniform? The meaning of uniform is that अगर यहाँ पे मास m है, तो यहाँ पे भी मास m है, यहाँ पे भी मास m है, यहाँ पे भी मास m. अगर एक ऑब्जेक्ट नॉन यूनिफॉर्म है, तो उसमें ये मासेस डिफरेंट हो सकते हैं. Right? So whatever I am saying will not work if you take a hemisphere of wood and hemisphere of iron and stick them together to get a sphere. Right? So this sphere would be symmetrical, no doubt about it, but it would not be uniform. And therefore, the center of mass will not lie at its geometrical center. So this means that a circle can be replaced by, so this is the original circle which has gone, which has faded away, and it can be replaced by a point particle located at the center. Right? So similarly, a square, a square will be represented by a square like this, will be represented by point particle like this. Okay? And a triangle, if you have figured it out, a triangle will be replaced by triangle गायब हो गया, by a point particle located at the centroid of the. आया सबको समझ में? This is understood by everyone. Symmetrical uniform objects have center of mass at the geometrical center. Now, I want to talk about 3 types of densities. Okay, this is very important. I may have talked about it before. I will certainly talk about it again. So, 3 types of densities of mass. Okay, now you have in your journey up till class 10 heard about only one type of density. In reality, density is a very generalized concept and is applied in a spectrum of situations. So we can talk about density of mass, we can talk about density of energy. In fact, we will be talking about the quantity called energy density when we study electrostatics and magnetism. We can talk about the density of charge. Again, we'll be talking about that when we talk about electricity. We can talk about density of current, which we will be talking about in the topic of magnetism. Okay, एक minute. Class में हो. कभी call back. Very good, Shaunak. Yes, density of probability, which you would have studied in chemistry. The whole concept of quantum mechanics is based on this thing called probability density, right? We will not have a chance to discuss quantum mechanics. It is a wonderful, fascinating area of study. So I want to talk about three types of densities of mass. Okay, and their symbols are lambda, sigma, rho. Okay, so this is called the linear mass density. Okay, now what do we mean by linear mass density? Supposing I take paint and I take a kilogram of paint or 2 kilograms of paint and I paint it over a wire, very thin wire. And then if I cut 1 meter of the wire and I scrape the paint off, that tells me the amount of paint per unit length of the wire, right? That is called the linear mass density. Is equal to mass upon length, right? And for us, what will be useful will be that an element, if we choose an element in this uh, in this thin wire of paint, then that element will carry a mass of lambda into dl, because lambda is the mass per unit length. Okay. Good. Yes. So this is called the surface. Sometimes people like to call it superficial. I don't think I will ever use the word superficial. So surface mass density, and this is equal to mass upon volume. And this tells me that dm is equal to sigma dA. Right? Now dA is a very, very tricky thing. Okay, so to explain to you dA, I must rub this out. So dA is a very, very tricky thing. Okay? dA means an element of area. एरिया है एरिया है बिल्कुल हाँ. Unfortunately, you cannot integrate this. Unfortunately, you cannot integrate this because अच्छा ओ मास बाय वॉल्यूम लिख दिया गया. एक्चुअली मैं भी क्लास 10 तक तो वही पढ़ा था. मेरे भी दिमाग में ना डेंसिटी अच्छा मास अपॉन वॉल्यूम, सो सबकॉन्शियसली लिख दिया मैंने. So dA is the element of area, and you cannot carry out or you cannot integrate dA because this in maths is called double integration. Right? We are not going to study double integration. You are not going to study double integration in mathematics also. Therefore, whenever you get dA, you must be sort of very happy because uh, dA can only have two values for you. One is 2 pi r dr, right? So 2 pi r dr का मतलब हुआ that chosen element is a ring of radius r and thickness dr. Right? We will come back to this. Just let me complete what I'm trying to say. If you are understanding, it's good. Otherwise, don't worry. We will come back to this. This is basically now the bread and butter of physics. Lambda, sigma, और यही अब आपके सामने आने वाला, right? So dm is equal to sigma dA. dA is the element of area, and it is either going to be 2 pi r dr, that is chosen element is a ring of radius r and thickness dr. Okay. Now, what is happening here? You remember I told you the story about the marble and the paint. तो मैंने एक मार्बल लिया, उसके ऊपर वाइट पेंट किया, फिर उसको रख दिया, फिर अगले दिन आके ब्लू पेंट किया, फिर रख दिया, फिर अगले दिन आके रेड पेंट किया, फिर रख दिया, and so on and so on. And I keep on doing this for 10-20 years. After 20 years, the marble has become big sphere, and every day I colored it with a different color of paint. And now if I cut it down the middle, okay, if I just cut it exactly down the middle and look at the cross section, I am going to see different color rings, and each ring will literally be the thickness of a layer of paint. Therefore, it will be very, very thin, and uh, and uh, uh, this will be the element. So if you look at the cross section, you will see a disc, right? I hope everybody can visualize what I'm saying. So you are seeing a disc. Actually, तो आप हेमिस्फीयर का bottom part देख रहे हो, लेकिन for a moment just imagine that this is a disc. Then the disc is made up of rings. Just like I think I discussed that the sphere is made up of hollow spheres, the ring is made up of discs. So if you choose one ring, then that ring is going to have an area of 2 pi r dr. Or it can be L dx or L dy. Sorry. So what this is a strip of length L and thickness dx or dy. We will, and again I'm repeating the fact that this will come up again and again and again in front of us. तो मैं पहले पूरी चीज बता दे रहा हूँ, और जैसे जैसे आती रहेगी I will refer back to this slide. The third type of density is the one you know so well. It is called the volume mass density. Ring is made of disc, nahi, disc is made of ring. Volume mass density. How do you construct a disc? To construct a disc, you take a point and then you put a ring of radius dr. हाँ मैं बता रहा हूँ. Then you put another ring. Then you put another ring of increasing radius. 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 Until you come to this ring. Okay? ये मैंने थोड़ा enthusiasm में टेढ़ा कर दिया. Until you come to this ring. अभी आया समझ में how the disc is made up of rings? Okay. Now, where did I get the 2 pi r dr from? So let's say that I consider a ring of radius r. And this ring of radius r will have a thickness of dr, right? This is what we discussed. And now what I want you to do is imagine in your head कि ये जो ring है, ये red color की जो ring है, इसको मैंने क्या किया कि एक पॉइंट से काट के इसको मैंने स्ट्रेटन आउट कर दिया ऐसे. Okay, imagine that I have straightened it out like this. So this is the red ring. Okay, now can you tell me the length of this red ring? Can you tell me the length of this red ring? Thickness of the red ring? dr. So dA will be equal to 2 pi r dr. ठीक, आया समझ में? अभी क्लियर है? हाँ, this is made up of ring. डबल इंटीग्रेशन कैसे करते हैं वो भी मैं कुछ बता दूंगा नेक्स्ट चैप्टर में, राइट? व्हेन यू आर क्योंकि मेरे को बहुत डर लगता है जब मैथ से मैं ओवरलोड कर देता हूँ ना. आई in the next chapter I'll show you double integration. Okay, so now I hope this is clear. We come to the volume mass density, which is mass upon volume, which is dm is equal to rho dv. Now again, dv, which is a volume element, you cannot integrate. You cannot integrate because this involves something called triple integration. क्या हो रहा है ये मैं बता देता हूँ. क्या हो रहा है ये मैं बता देता हूँ. Supposing you have an xy coordinate like this, and supposing that at a distance of x, you choose a strip of width dx. Similarly, at a distance of y, you choose a strip of width dy. This is the area. This is the area dA is equal to dx dy. Integration of dA is equal to integration dx dy. This is double integral. And similarly, if you have three-dimensional case, right, so it will be exactly similar to this. It will be exactly similar to this. So what you'll end up with, is a teeny tiny parallelepiped here, where this length would be dx, this length would be dz, and this length would be dy. Right? So you would get dv is equal to dx dy dz. Therefore, integral dv is equal to triple integral now dx dy dz, right? Which is beyond our syllabus. So I'll show you some. If we get time, I'll show you hints of this integral of dx dy dz. Okay? So if you have a volume element, again you can't do anything. Yeah, again you can't do anything except you can say that this is a spherical shell, and the spherical shell has a volume of 4 pi r square dr. Can you guess what this is? अगर यहाँ पे ये 2 pi r dr आया तो ये circumference था और ये thickness था. Can you see what is 4 pi r square dr? हाँ बिल्कुल सही prediction. What is 4 pi r square dr? बताओ भाई. 4 pi r square dr में 4 pi r square क्या होगा, dr क्या होगा? 4 pi r square क्या होगा, dr क्या होगा? 4 pi r square will be the, नहीं बेटा, वॉल्यूम इनटू थिकनेस आर्यन पता नहीं क्या ही आ जाएगा. हाँ यस. डिस्क कहाँ से आ गया? डिस्क कहाँ से आ गया? सर्कल भी नहीं रहेगा पार्क. नहीं, सर्कल का एरिया 4 पाई आर स्क्वायर थोड़ी ना होता है. हाँ, ऑरेंज पील. वाह, बहुत बढ़िया. गुड 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 गुड. हाँ, सरफेस एरिया ऑस्ट्रिया. just hold on. हाँ, so spherical shell का ये एरिया होगा dB, or you may get a plate. In that case, it will be a dx or a dy. We'll see this, like I'm saying, we'll see this again and again. So now using this two things that we have learned. One is the three types of densities of mass, and the other is that the symmetrical uniform objects have center of mass at geometrical center. I now want to solve this question. So since the circle and the square are symmetrical and they are uniform, therefore the circle is basically a point particle here and the square is a point particle here. The coordinates of this point are 3a comma a. Coordinates of this point are a comma a. So the y coordinate of center of mass is very easy. It is m1a plus m2a upon m1 plus m2, which is equal to a, right? So this is a very good thing, very obvious thing, that that uh, if multiple particles have if multiple particles have uh, the same x coordinate or the y coordinate, then it is guaranteed. Okay, then it is guaranteed that uh, the x coordinate or the y coordinate of center of mass will be same. Okay, but what about the x coordinate here? Well, I know that the x coordinate of center of mass is given by m1 x1 plus m2 x2 upon m1 plus m2. And I also know x1 and x2, but I don't know the mass. But again, like I said, I'm too lazy to write out things for, just for the decoration. Whatever I write because it is giving you some mathematical hint. They are cut from the same material. If they are cut from the same material, that means that these two guys have the same density. But which kind of density? But which kind of density? वेल सर्कल एंड स्क्वायर की बात हो रही है, इसका मतलब थिकनेस तो होना नहीं चाहिए, या होगा भी तो बहुत ही स्मॉल होएगा. Therefore we are talking about surface density. Okay, so m1 will be surface density multiplied by the area, which is equal to pi into a square into the x coordinate, which is a. Okay, plus density into area into the x coordinate divided by density into area, which is mass, plus density into area. Okay, what will cancel out? Well, sigma should cancel out, as it should. A square will cancel out, upper niche, and I will be left with simple a 5 plus 12 divided by 5 plus 4. ठीक है, आया समझ में सबको? Repeat for sphere and a cube. Right? So the question is the same, everything is the same, except I don't have a circle and a square, I have sphere and a cube. So can you tell me, kept in the same exact way, everything is the same. Can you tell me what is the center of mass, location of the center of mass? Yes, of course, yes, Mahek, yes. तो जब हमारे पास 3 डायमेंशनल ऑब्जेक्ट आ जाएंगे तो हम वॉल्यूम मास डेंसिटी लेंगे, 2 डायमेंशनल आ जाएंगे तो हम, हाँ, वाई और जेड तो सेम ही रहेगा ना, वाई और जेड सेम। जब 2 डायमेंशनल ऑब्जेक्ट आ जाएगा सरफेस मास डेंसिटी लेंगे, जब 1 डायमेंशनल ऑब्जेक्ट आ जाएगा तो लीनियर मास डेंसिटी। हाँ, so it is, the diagram is exactly the same. The coordinates would be a comma 0 and 3a comma a comma 0. खुशी मैं बोल रहा हूँ इसलिए भाई, मतलब ये जो इनका जो सेंटर है, ये जो स्फीयर और क्यूब के अगर बात करेंगे तो ये जो सेंटर है यहाँ पे z कोऑर्डिनेट 0। हाँ, बेसिकली x कोऑर्डिनेट ही निकालना है, y और z तो निकालने की जरूरत ही नहीं है, केवल x निकालना है। हाँ, so basically we are going to have x coordinate of center of mass, x coordinate of center of mass is equal to, हाँ ये करेक्ट आंसर है अनीश। हाँ, नहीं ये शिवन, ये हाँ ठीक तो है ना, 24 × 372, तो हाँ सही है। So x coordinate of center of mass is equal to, ये शानक थोड़ा गड़बड़ क्या डीए लिखा हुआ है, डेंसिटी इनटू वॉल्यूम इनटू द एक्स कोऑर्डिनेट। 4 5 + 9 देखो प्रतीक्षा नहीं आएगा मेरे ख्याल से, तो मैं करके देखता हूँ। डेंसिटी इनटू, इतना वेरिड आंसर क्यों आ रहा है ये, 8a³ इनटू 3a divided by density into 4/3 pi a³ plus 8a³. So this is equal to a 4/3 pi plus 8 3 मैं भूल गया, 24 नहीं, 24 है वो, याद है भैया, 4/3 pi. So this will be equal to a 4 pi plus 4 कैंसिल हो सकता है क्या? अच्छा इसलिए वैसा आंसर आ, ओके ठीक, सॉरी, अपॉन अपॉन क्या आएगा, 4 pi plus 8 × 3 24 इज इक्वल टू a इंटू, कितना आया प्रतीक्षा, सही निकला था, 5 + 8 नहीं, हाँ नहीं, क्या हो गया यार मेरे को, 18 टेबल ही भूल गया हूँ, और नीचे क्या आएगा 6। ओके, नेक्स्ट क्वेश्चन। बहुत बढ़िया बात है। Oh, okay, very nice. Can you repeat for a sphere? नहीं, गलत है. हाँ, good Arif, yes. Okay, so what we do is we have a concept in physics that is called the concept of negative mass. Now, this is a mathematical concept. It has got nothing to do with reality because there is no such thing as negative mass. So, if I have a full solid disk, if I have a full solid disk of positive mass density plus rho, yes. And if I have another disk of density minus rho, okay, of density minus rho, then नहीं पा अच्छा उसके लिए बता रहा है क्या हाँ सही then what I can do, okay, and I cannot sort of show it to you here, but what I can do is I can pick this guy up, okay, pick this guy up, put it here, pick this guy up and put it here, and if I do that, then basically I am going to end up with a disk, if I can draw, with a disk of positive mass density, a solid disk of positive mass density, which is superimposed with a disk of negative mass density. And wherever this superimposition occurs, जहां जहां मैंने ये जहां पे ये नेगेटिव मास डेंसिटी और पॉजिटिव मास डेंसिटी एक साथ एग्जिस्ट कर रहे हैं, वहां पे हमें क्या दिखाई देगा? जहां पे नेगेटिव मास डेंसिटी और पॉजिटिव मास डेंसिटी हम एक साथ एग्जिस्ट कर रहे हैं, वहां पे हमें क्या दिखाई देगा? वहां पे हमें दिखाई देगा कि कुछ नहीं है, बिकॉज उस रीजन में मास डेंसिटी जो नेट है वो जीरो हो जाएगी. तो हमको यहाँ पे दिखाई देगा देयर इज ए hollow space. Right? I'll try to repeat this. So I take a disk of positive mass density and I take another disk of negative mass density and I place the negative mass density wala disk I place the negative mass density wala disk into the positive mass density wala disk. Right? I literally shove it inside. They are again. This is not physically possible, only mentally. So I take the red wala disk and I keep it on top of the blue wala disk. Not only do I keep it on top, I actually push it inside so that the blue wala disk and the red wala disk are actually coexisting in the same space, right? Which is impossible. पॉजिटिव नेगेटिव मास खुशी कुछ नहीं होता है, केवल एक मैथमेटिकल कॉन्सेप्ट है, राइट? एक मैथमेट एक हाइपोथेटिकल एक इमेजिनरी डिस्क है जिसका नेगेटिव मास डेंसिटी, इन रियलिटी देयर इज नो सच थिंग, एंड इन रियलिटी मैं दो डिस्क को एक साथ एग्जिस्ट भी नहीं करवा सकता हूँ. क्या आप दो क्रिकेट बॉल को लेके एक के अंदर एक डाल सकते हैं? नॉट पॉसिबल, because cricket ball number 1 is occupying its space, cricket ball number 2 is occupying its space. लेकिन यहाँ पे what I'm saying is that I take the blue disc and I take the red disc and I put the red disc inside the blue disc so that they are actually occupying the same space, right? And if positive density and negative density are occupying the same space, that means that the net density in that space must be zero. That means that there will be no mass there. Okay? So using this concept of negative mass, I am going to say that look, this guy has coordinates or center of mass here, which is r comma 0. This guy has coordinates of center of mass 0 comma 0. Okay. Now please notice x coordinate of center of mass is equal to density into the area, which is pi into 4r square into the x coordinate plus the density into the area. Sorry, नहीं बचा, गलत गलत आंसर आ रहे हैं. Plus minus rho, this is the density, into area pi r square into the x coordinate r. I want to write the x coordinate with black, into r whole upon sigma into the area plus sigma minus sigma into the area. So this will be equal to, ऊपर तो जीरो है, जीरो हो जाएगा, सिग्मा कैंसिल हो जाएगा, ये सिग्मा ये सिग्मा ये सिग्मा कैंसिल हो जाएगा, आर स्क्वायर कैंसिल हो जाएगा, पाई कैंसिल हो जाएगा. So I will get the answer as minus r by 3. Okay, and again I want you to repeat for sphere, repeat for r. Sorry. Repeat for sphere. हाँ बिल्कुल सही है. Okay. Do this one now. ओह, मैं म्यूट पे बोले जा रहा हूँ, बोले जा रहा हूँ, बोले जा रहा हूँ. Okay. So to do this question, what we have to do first is realize. हाँ, हाँ, सही है. So to do this question, what we have to realize is that for continuous objects, हाँ, for continuous objects, xum is equal to summation mi xi divided by summation mi becomes integration of xdm divided by integration of dm. Y coordinate of center of mass summation mi yi upon summation mi becomes integration of ydm divided by integration of dm. Okay. So what do I mean by this? What is the you know meaning of integral xdm? You should be absolutely clear on this. So if I have a three-dimensional object like so, now you have to visualize this, okay? Because I cannot draw it. This is a two-dimensional plane, so I cannot effectively draw three dimensions. But ये जो मैंने blue object बनाया है, it is a three-dimensional lump of material. जैसे आपके घर में ना आटे को नीड करके जैसे रखा जाता है, वैसे ये एक lump of material. इस lump of material में मैंने एक element choose किया इस तरीके से, और इस एलिमेंट का मास dm है, और इस एलिमेंट के जो x, y और z कोऑर्डिनेट्स हैं, दे आर x, y and z. Okay? So the x coordinate of center of mass will be given by integration of this guy, this x coordinate, if I can write properly, into dm divided by integral dm. Y coordinate of center of mass similarly will be given by integral y dm divided by integral dm. Now you may ask कि ये integral dm लिखने का क्या मतलब है? Why can't you just write m? And the reason is that I will prefer to write it this way because later on it is going to be convenient. If I write m, then later on it is going to create problems. So I'm going to write dm, integral dm, not m. So using this change in formula, or using this modification in formula for continuous objects, I want to now come back to this and I want to tell you how to find this out. So we have x and then dx, y and then dy. So the x coordinate of center of mass will be given by integral x dm divided by integral dm. And we must be very clear about एक और चीज है जो मैं भूल गया बताना. So I must write this in red. In case elements are not point objects, then x and y are coordinates of center of mass of the element. Okay? So in case, as we will see, आज तो नहीं देखेंगे, next class में देखेंगे. In case the elements that you have chosen are not point objects, then this x and this y will become the x and y coordinates of whatever element you have chosen. Okay? I'm going back now to that slide. So integral x dm divided by integral dm. The elements are here point objects, so there is no complication involved. So this will be equal to integral of minus x, क्योंकि इसका x coordinate minus x है, into dm, and there I'm going to write lambda dx. This is why I taught you this thing. So dm is equal to lambda into length of element. यहाँ पे dl लिखा है, वहाँ पे dx हो जाएगा, फिर उसके बाद dy हो जाएगा, right? That will be variable. That will keep on changing depending on what you have chosen. Divided by integral lambda dx, because that is what is dm. And then you have to choose the limits of integration, and the limits of integration are always chosen by looking at the extreme elements. This is one extreme element, this is one extreme element, this is one extreme element. So on the vertical part of the chain, every element has an x coordinate of 0, so I don't need to worry about that. On the horizontal part of the chain, the x value will vary from 0 to 2l by 3. Therefore, we must have the limits as 0 to 2l by 3, 0 to 2l by 3. Now, if you look at the integration, then lambda comes out of the integration, plays no role, gets cancelled out. So I'll just take out minus lambda from here, x dx 0 to 2l by 3 divided by lambda integral dx 0 to 2l by 3, and this will become uh, x square by 2 divided by x. Please don't put the limits here. 0 to 2l by 3, 0 to 2l by 3. This will be equal to 4l square by 9 divided by 2l by 3, which will be equal to minus 12 by 2. Sorry, not a sorry, by 12 by 3. Okay, and similarly, the y coordinate of center of mass will be integral y dm divided by integral dm, and this will go from 0 to minus l by 3, 0 to minus l by 3. So this will be equal to integral 0 to minus l by 3 minus y uh, uh, दोनों को माइनस नहीं ले सकते हैं, या तो मैं एक को माइनस लूं दूसरे को ना लूं. So I'll take the limits as negative. I'll put just a y here. Lambda dy divided by integral dm, which will be lambda dy 0 to minus l by 3. Right? Please work this out. Tell me कितना आएगा ये l by 3 वाला. L by 9 आएगा. Please work this out. Tell me the answer. माइनस y लिया तो लिमिट्स को 0 to l by 3 लेना पड़ेगा. हाँ कर सकते हैं, बोल सकते हैं। अनम्यूट तो है पार्थ।
सर
हाँ
अगर सर ये करेक्ट नहीं होगा ना लेकिन पूरी तरह से अभी,
क्या?
सर ये करेक्ट नहीं होगा ना पूरी तरह से अभी?
हाँ मैंने गलती कर दी है ना
सर सबसे
हाँ मास मैंने गड़बड़ कर दिया, सॉरी।
सर फंक्शन कांस्टेंट नहीं रहेगा क्योंकि टॉप मोस्ट पे मास अभी
हाँ हाँ हाँ
और आएगा।
हाँ मैंने गलती कर दी, एक मिनट सही कर रहा हूँ। So this will be the total mass नीचे ना, total mass. So this will be 0 to L lambda dx. So we'll get minus x square by 2 divided by x 0 to 12 by 3 0 to L. This is equal to minus 2L square by 9L. 9 आएगा 6. This will be minus 12 by 9. And here also it will not be 0. हाँ मैं बता रहा हूँ सिली मिस्टेक है मेरी पार्ट में। इसलिए है क्योंकि ऊपर वाला इंटीग्रल मैंने इनकम्प्लीट लिखा हुआ है। मैंने जो ऊपर वाला इंटीग्रल लिखा है वो इनकम्प्लीट लिखा है। इनकम्प्लीट इसलिए है, लेट मी जस्ट चूज अ डिफरेंट इनकम्प्लीट इसलिए है क्योंकि हमें यहाँ पे सबके कोऑर्डिनेट्स लिखते हैं। So it will be equal to integral 0 to 2L by 3 minus x lambda dx plus 0 lambda dx. यहाँ से जहाँ भी लिमिट जाएगा उससे मेरे को कोई मतलब नहीं है। बट द पॉइंट इज दैट जो चेन के ये वाला पोर्शन है उसके कोऑर्डिनेट्स तो नहीं है हमारे पास, लेकिन ये वाले पोर्शन के ये वाले पार्टिकल्स के सबके x coordinates 0, right? So basically what you are doing is that you are adding up all the zeros here. So this actually goes away, this becomes 0. You end up only with this. But नीचे तो total mass आना चाहिए ना, mass of all the elements आना चाहिए यहाँ पे. So this will be 0 to L lambda dx. आया समझ में? यहाँ पे टोटल मास आना चाहिए। Just like in this case 1 kg का मास 1 kg का x coordinate तो 0 था, right? So the x coordinate of 1 kg is 0, but यहाँ पे तो आया 1 ना, यहाँ पे आया 1, यहाँ पे आया 1। I think ज़्यादा दिमाग लग गया है मेरा। minus 12 by 9. You can figure out the y code. minus L by 8. हाँ ठीक है अनीश, ये भी सही है, बिल्कुल सही है। तो ये जो अनीश ने आपने किया, what Anish has done, and I think what was suggested, I think Shivan suggested this, that since the chain is uniform, and you can do this, right? This is absolutely valid. Since the chain is uniform, just replace this part of the chain by a point particle at L by 6, and replace this part of the chain by a point particle at L by 3, and then simply calculate the center of mass. That will also also give you the correct answer. थोड़ा masses का ध्यान रखना पड़ेगा, बाकी सब correct है. Okay, so I'll stop here and slides देख लो भाई. पहला, I don't think you need to probably take a screenshot. First slide, I described about what we have done up till now for a point particle. Second, how to locate, basically how to draw the position vector of a system of point particles. Screenshot लेते जाना भैया जिसने नहीं लिया है. Third, the formula for the x coordinate and the y coordinate of center of mass of a system of discrete particles. Two questions we did, three actually. Then meaning of symmetrical and uniform objects. Okay. इसमें मुझे OnePlus फोन की याद आती है. उसमें केवल 3 फिंगर से स्वाइप डाउन कर दो तो स्क्रीनशॉट हो जाता है. हाँ, सब पे आ रहा हूँ कुछ नहीं, सब पे all slides I'll show. Double and triple integration you don't need to worry about right now. Next chapter, actually उसका कहीं such use नहीं आता है, but I don't know, sometimes it may make the problem easy. कौन सा वाला प्रतीक्षा? Previous slide, ये वाला. हो गया? This is very important. Disk is made up of rings, and this is how you find a ring. Then I think this is the continuation of a problem we did, and another one. Screenshots. Then the concept of negative mass. Remember, this is just hypothetical, not really true. Mathematical tool. So, आप instead of saying ये 0 है, I'm saying this is 1 minus 1. Both are equivalent. हाँ, minus L by 18 आ रहा है, कितना आ रहा है? I don't know. L by 18 ही आ रहा है ना इसमें? हाँ. Okay, and the last slide is this we are going to use in the next class. Next class में ये main feature ये है. Okay. Chalo. So I'll see you in the next class. Bye bye.